Hello, algebra students. Mr. Lawrence here, and I couldn't do a real long one. I started getting embarrassed. I'm actually sitting in a McDonald's while my son is playing, and I'm recording a video just for you. Hopefully, you're watching this and getting ready to do your best on a test. If you hear me talking with my mouth full, I apologize, but it is dinner time. You can't really blame me, can you? Just so you don't see food flying out of my mouth and hitting the screen, I think you'll be okay. All right, enough with the Commodian Act. Anyway, here we go. Today, I can determine when to solve a system by elimination, substitution, and graphing. I can solve a system of linear inequalities, okay? That's what the topic of the video is going to be today. I'm looking at the red system, the green system, and the blue system. And I'm going to wonder, I look at the red one, and I think elimination is a good way to do it because I could easily multiply the second equation by -2, and the x's would cancel, right? I could also do this system by elimination, or excuse me, by substitution by solving for the x. So I'm not sure which one I want to do at the moment. So I'm going to mark an S for substitution because I think substitution would be a good choice. And I'm also going to put an E for elimination because it could be a good choice. Excuse me. The second one, the green system, let's see, looks like I could solve for y pretty easily, so substitution's not too bad. Elimination might work. Okay. By the way, should I graph any of these? Well, let's see. I don't think I want to get y alone in this first red equation, 2x plus 5y. It is in standard form. The x-intercept isn't too bad. The slope is easy. So graphing is a possibility for the first one. And the second one, again, I don't want to get y alone. I think I'll go from standard form. The x-intercept's easy, but it's not going to fit on my graph if I count by ones. So I'll have to count by something else. So maybe I won't do graphing on that one. Let's see, number two, the top equation, getting y alone would be easy. Slope would be easy. Y-intercept would be easy. Yeah, that's a good choice. Getting y alone in the second one, the graphing is definitely a possibility here. I'm going to put a G there. Okay. Number three, this equation is in slope-intercept form, and I'm sure Austin can tell you the slope is -1, not 7. So that's good for graphing. This is in standard form, and both intercepts will be easy, and the slope will be easy. So graphing would be a good choice for this one. Okay, substitution would be a good choice. Elimination, not so much, because with elimination, I would have to rearrange the equation so that it's at x plus y equals 7, which isn't that hard to do, but then I have to multiply everything by 2, and the more steps I take, the more likely it is I'm going to make some silly error. So I'll tell you what, I think this one looks the most friendly for graphing. So I'm going to graph this system, and I'm not sure why it's orange, but it is. I thought I had it blue, but I must have changed it. Anyway, I think for this one, let's see here. I think I like elimination for this one. I just double the top equation, and that will work very well. And then for this one, I think I'll go substitution then. By default, I have to, right? Because on the quiz Thursday, you're going to have to do one by each method. So let's do the substitution problem first. So I'm going to solve for x in this second equation. When I do that, I'm going to get x equals 6y minus 11. All right, I'm going to say 2 times the quantity of 6y minus 11 plus 5y, and that'll equal 12. I'm going to distribute and get 12y minus 22, and that's going to be plus 5y. That's going to equal 12. I'm going to combine my like terms and get a 17y minus 22 equals 12. Take the 22 to the other side by adding, I'll get 17y. That's going to equal 34. Divide by 17 to get y, and y is going to equal 2. All right. Now to get x, I'll just use this equation right here, and I'll get x is going to equal 6 times 2 minus 11. I think most of you can tell me that that's going to be 1. So x is going to be equal 1. So these two lines cross at the point. Oops, did that backwards there, pardon me. 1, 2, and there you go. All right. right, let's do the green equation now. Let me make some room here. Okay, I said I was going to do this one by elimination, and I'm going to multiply the top equation by 2. All right, so we're going to get 6x plus 2y equals 20. And then the second equation isn't changing. I like the fact that I didn't have to multiply both equations. I'm going to go ahead and add them together. Should put a plus sign there. I'll get 9x. Those will cancel to 0. 36. X is going to equal 4. Now I can use any one of these equations. I think I'll use this one because the y is almost already alone. And I'll do 3 times 4 plus y equals 10. That'll be 12 plus y equals 10. Subtracting 12 from both sides. Y equals -2. So I will get the point for -2. All right, there we go. I'm tearing right through these. This one here, I said I was going to do by graphing. So let's go to my graph. There it is. I know the y-intercept of this equation is 7. 1, 2, 3, 4, 5, 6, 7. And I know that my slope is -1/1. So I'm going to infinitely clone him. And we're going to get some points going like this. Now remember with these, I like to, before I draw in the lines, I like to see if I can find out where they're going to cross each other. Okay, now how did I do that? I knew it was in slope-intercept form. All right, this one's in standard form, AX, AX plus BY equals C. I'm going to find an intercept. How about if I find the y-intercept? Well, that's C over B, right? So the y-intercept is going to be the point 0, -2. So let me graph that in a different color. 0, -2 would be right there. Now my slope is going to be -2 over -2, which is 1/1. So my slope is going to go like this. My line is going to go like, oh, and look at that. Ooh, they're not going to cross exactly at a point, are they? All right, so that makes this one a little bit ugly of a solution, but not difficult to do. I chose it. I don't know what the solution is ahead of time, right? So I'm going to make him a little bit thinner so I can tell what's going on here. There we go. He's nice and thin now. Went on a diet. And let's get another line here. And we're going to make him the same thickness so that we're comparing apples to apples. All right. Let's see, make him nice and thin. We'll make him a different color. And we'll put an arrowhead on him like that. And there we go. All right, so I see that they're crossing right there. Well, 1, 2, 3, 4, 5, maybe 4.5. And then the y coordinate be 1, 2. Man, it sure looks like 4.5, 2.5. I don't know if I'm right though. I'll tell you what, let's go ahead and solve this one using substitution because y is already alone. And let's see how good my estimate is. So I'm going to have 2x minus 2 times the quantity of 7 minus x. And that should equal 4. So I'll get 2x minus 14 plus 2x. And that's going to equal 4. I'll get 4x equal to 18. And divide by 4 on both sides. That's the same as 9 over 2, where x is 4.5. Hey, I hit that right on the nose. Pretty good estimation. I'm feeling pretty good about it. Okay, now if I, let me rewrite that. That looks terrible. Okay, now for the y coordinate, I'm going to use this equation here, and I'm going to get y equals 7 minus 4.5. Well, that's going to have 7 minus 4 is 3, but this is more than 4, so it'll be 2 And what makes that a hole? 5/10. There we go. I nailed it. I nailed it. Actually, I did such a good job graphing. I was so precise in my graphing that it was easy to tell it was just about the middle. Now, I wasn't 100% sure, but I felt pretty good about my estimation. After I checked it, I'm feeling really good about it. Okay, finally, we're going to solve a system of inequalities. Now, let me ask you this yellow one here, what form is it in? What's that, Gotham? Yeah, you're right, Gotham. It's not in any form. So I'll tell you what I'm going to do. I'm going to go standard form on it. So I'm going to subtract 2y from both sides. And then my equation is going to become, or my inequality is going to be x minus 2y, and that's less than or equal to 0. All right, so my y-intercept is going to be the origin, which means my x-intercept is also the origin. And let me infinitely clone him. And now I need my slope. Well, it's going to be -1 over -2, which is 1/2. Rise 1, run 2. Rise 1, run 2. All right, now it's equal to, so it'll be a solid line. So, back to, oh, that's the wrong place. Okay, let me see that. And let me make him nice and thin. And remember, I said it's going to be a solid line because it's equal to. All right, so now I got to decide which side of the line to shade. Well, I'm going to plug in the origin. All right, sorry about that. I got interrupted by my son temporarily. So I'm going to put 0 is less than or equal to 2 times 0, which simplifies to 0 is less than or equal to 0. Uh-oh, Mr. Lawrence, you forgot. You can't use the origin as a test point. Why not? Because the line's going through the origin. So what should I use for a test point? How about the point 1, 0? Okay, so I'll plug 1 in for x. I will multiply y, or 2 by y, which will be 0. And so I'll get 1 is less than or equal to 0. Is that true? Absolutely not. Since it's not true, I can go ahead and shade the other side of the line. Now the line is included in my shading. Oops, I'm going over a little bit. Okay, so I'm going to shade over here. Now you might think I'm coloring dark. I just do it for the visual effect. Remember, with your pencil, you should color light and go to shade different directions until you can tell where it happens. Okay, so let me try to see if I can clean that up just a little bit, just a little bit. Okay, and okay, that looks a little bit better. All right, let's move on to the blue equation. It is in, or inequality, it's in standard form. And the y-intercept's kind of ugly, but the x-intercept is pretty. It's 2, 0. So I'm going to go x-intercept of 2, 0. How did I do that? I did c over a. Now my slope is negative a over b, negative 2/3. Down to 1, 2, 3. Okay, up to 1, 2, 1, 2, 3. All right, up to 1, 2, 3. And there you go. All right, so let's see, down to 1, 2, 3. Okay, again, it's going to be a solid line. How do I know? Because it says equal to. If it only said less than or greater than, it would not be a solid line. And we're going to put an arrowhead on that. And we're going to make it nice and thin. And I'm going to change that to blue. And now I got to see which side of the line I need to shade. Well, I'm going to plug, can I plug the origin on this one? Sure, because the line doesn't go through the origin. So this time I'm going to plug the origin in. And I'm going to get 2 times 0 plus 3 times 0 less than or equal to 4. Okay. Left-hand side will simplify to 0 less than or equal to 4. Okay. So I got a true statement, so I will shade where the origin is. Well, let's see here. Okay, so that'll be below the line. Going to be shading Shading down here, and it's tough to toe that really well. And there we go. All right. So the solution is this green region. And notice I keep shading over here, um, where it's just blue, because that's part of the solution for the one line. But for the system, the actual solution is this triangular region right here. All right, very good. That's your video for tonight. Mr. Lawrence signing off. Have a good night.